Buckle up, buckaroos. Today we got a Sigma lesson for y'all, no cap. So tune in as if you're in Ohio or something. I don't really get how to use that one. Here we go. We already talked about this. I should have started recording a few minutes ago. All this information right here is really all that we need to graph most of this. So as I'm looking, I need X values to go how far left and how far right. So what's the smallest X value you see anywhere in here? -2, right? So I need to go past that. And I'm thinking out my scale, I'm going to go like -3 at least. What's the furthest right value I need? So check it out. If I do this, I can call this 4. This would be 2. Here's my 0, -2, and -4. Now I'm going to eyeball this. Y scale. Don't know how big it needs to be yet, but I know for sure I need one number on it. What's the one number that I have for y? -1/3. So decision time. You guys probably normally make stuff square. So 1 square up is 1 unit and 1 square right would be 1 unit. But that's just by convention. That's just because it's convenient. 1/3 is not easy to find if I just make one little square worth 1. Can I change it so that that's 1 instead? Yeah, which means down here we would have a -1. If you don't like this scale, that's okay. You don't have to use mine. All right, so we have X and Y. Before we continue on, any issues or questions about how I've set up this graph? Okay, what am I going to put on the graph now then? How am I going to put these guys on? Lines, specifically vertical lines, right? So they're asymptotes at -2. Can't touch it, won't touch it. +1, can't touch it, won't touch it. +3, can't touch it, won't touch it. Okay, horizontal asymptote. These ones are always weird. I'm going to let you do whatever you want to do, but I like to do it there so I can see both. Okay, I will not touch the vertical lines. I might touch the horizontal ones. We'll see. Cool. Anything else I could put on my graph before I jump to the number table? Whoa, the number line. Other information that we could include. JV, what do you think? What's something I could put on here? Hey, the y-intercept, 0 and -1/3. I'm not going to measure it. Do you believe it? Close to 1/3. Okay. Any other values? -1 would be here. That's my y or my x-intercept, and a +3. Uh-oh. No, just kidding. +2. Less uh-oh. Sweet. Now, we have a lot of stuff going on here, and Riley, I agree with you completely, and other people who weren't as maybe confident to say so. Figuring out these other pieces can be a challenge. I know for certain what this section of the graph is going to look like. Not like a perfect idea, but like I have a good idea of what's going to happen here. As I'm looking, I know that these have to connect, right? Is there any chance that this turns back around and comes out? 0% chance. Why, Fern? Yeah, if it went back up, we would have found another x-intercept in here. Since we didn't, there's no other option. It must just trail down without bound. Okay, on this side, that root at -1, how many times did it show up in our factorization? 1 time. Why am I asking that question? Its multiplicity is 1, which is an odd number, which means I know the graph touches and turns, or crosses. It has to cross. So I'm going to do it from this side just so I can make it look a little bit nicer. Is it possible that this curve isn't perfect? I'm okay with it. All right, other things. Over here, 2 options. It can do that or that. One of those. Okay, this section, it could do this or it could do this. One of those options. And then over here, it's this or this. So we have a lot to figure out, which it seems like a ton of work, but it's really not. So we could, if you guys are just like dying to do it, we could go through the process of doing this. X, whole expression in here, f of x, and make a big table. Anybody psyched to make a big table with like actual values and such? Did you guys also just see a light cross across the room? Was he back there? Weird, because did he? I don't know. Strange. All right. So, if we're not going to use the table, what's our other option? Hey, let's do a number line real quick and make sense of it. Now, I didn't intentionally do this yesterday, but I'm going to right now. If I draw my number line directly below my graph, everything lines up. Anywhere that I have a root or an asymptote should be on here. So here, let's go ahead and say there's my -2. Here is my -1. And I'm going to make a comment here. It's a root. Here's my +1. Here's +2, which is a root. And then I get +3, which is not. There's a lot of intervals here. But notice, we have a bunch of it knocked out already. This whole section, I'm going to use this fancy shading. This whole section in here, we've already determined what it does. So we've already scratched that out, right? We don't need to consider that anymore. This section, these numbers are not super nice. But because this is a root, I can use multiplicity. I know that it's going to cross here. I just need to know if it's positive or negative on which side. So I have 0 preference here. I need you to pick a number either between 1 and 2 or between 2 and 3. What do you want, Charles? Between 1 and 2 or between 2 and 3? Cool. Give me a number between 1 and 2, and we're going to check it. 1.5 is probably the one that I would use as well. So check it out. Now, I'm going to have to look at my factored form. If I'm plugging in 1.5, and I'm just going to copy this, would you rather plug into the top or bottom? You personally. You'd rather plug, what's 1.5 squared? Are you sure you'd rather plug into the top? It's 2.25, which that's not a crazy one, but notice I'd have to do 1.5 cubed here as well. I think the bottom one's going to be easier, because do I really care about the number? I'm only doing this to check the what? We're just checking the signs of it. So let's dig in here. If we try 1.5, for example, let's just look. For 1.5, f of, I suppose. Don't care about the number, I just care about the sign. X minus 2, if we pick 1.5, is what sort of number? Positive or negative is all I care about. Negative. So check it out. I have a negative times 1.5 plus 1. Positive. So I know in the end that's a what? Negative. Okay. Down here, if you plug into 1.5, this factored form is a positive. How about the next one? Negative. And the next one? Positive. Which means the entire denominator is what? Negative. When I simplify negative over a negative, guarantees that right here on my graph, it's what? I get a positive right here. Okay. What does that mean on this graph? That in this section, the y values are positive. They're above, which means the only option on my graph then is it must do something like this. It does not turn around, and how do we know that? Louder? There'd either be another, so careful, there would have been another root, it would have been repeated, right? Or, because same idea, just different words, the multiplicity, exact same concept. Okay, middle section, knocked out. Both middle sections. Okay, out here, there's a natural choice, but I'm going to offer an unintuitive suggestion. What number would you guys pick for this last one? How many of you guys would go 4? Because that's a natural choice. Pick 10. Like something bigger, and it feels silly, but check this out. If we pick 10, positive, 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 positive. Guaranteed, I don't have to worry about like changing signs and stuff if I pick a big one. Positive over positive, guaranteed to be positive. That means on this infinitely large section of the graph, it's always positive. Don't just copy this. I want you to tell me what I've done wrong. That's always positive. What's wrong with it? So it would have a complex root. That's a big idea. But there's even more. It needs to get how close to the x-axis? Infinitely close, arbitrarily close, infinitesimally close, whatever you want to say. This graph does something like this. Okay, over here, the natural choice is like a -3. You can use -3. Could I use -10 as well? Anything in that interval works. Find me the sign of that one real quick. I'm going to give you a minute. Cool. God, I don't know. Do these middle sections look like a graph you've seen? Can you tell me what it looks like? Louder? Ooh, so it looks more like a cubic than a quadratic if you're thinking polynomials. Did you guys graph tangent functions last year? This looks like cotangent. Not quite tangent, but if that doesn't mean anything to you right now, that's okay. If we look at the graph of cotangent, I don't have Desmos open, it would look like this. Cool. Isn't that fun? Yeah, that's the hardest one from the entire assignment. If you chose to do this, I imagine you can see why I said do to it. That's fine. Cool. Here's where it gets real weird. You guys have a variety of problems that we need to check. So, we have seen two flavors of asymptote at this point. There's the vertical and the horizontal. Verticals are easy. Vertical asymptotes occur at the roots of denominator. Horizontal asymptotes, less easy. You have to compare the whats of the numerator and denominator. The degrees. Okay, now there is a very specific situation, and it doesn't happen super duper often, but we need to be mindful of it. I'm going to look. Here's the stuff we did yesterday. There's a problem that we just worked. I'll keep it up there for now. Last little section. Turns out one more flavor of asymptote that we get. So we're going to define for ourselves slant, or depending, you might see these as oblique asymptotes. Very specific situation. Just so you guys know, I'm going to put it in brackets so I don't have just parentheses, parentheses, parentheses. SA is the shorthand that I use. A slant asymptote. Now, if you think about the obliques, I always think of abdominal muscles because you have your abs here and then your obliques here. Your oblique muscles run diagonally like this, connecting down, so there's a slant part of it. Cool. As we're looking at these, very specific situation, but it's easy to pick out. Here we go. If, and we're still working with our rational function that's n over d, just so you guys are aware. If it turns out being the case that the degree of our numerator, or we'll start with the denominator, if the degree of n of x is exactly, I'm going to underline that because that part's important, exactly one more than the degree of d of x, if the numerator is exactly one more degree than the denominator, then we have a slant asymptote. We have a slant asymptote at, and I'm going to let you guys keep up or catch up because I'm going to drop down to the middle because this is a ugly part, but I want it to be really clear. It's always going to be a line y equals. Like they're going to be straight lines, which is nice. We're going to say it as y equals, and this is where the language is just kind of odd. When we look at this, the slant asymptote is n of x, the whole numerator, divided by d of x without a remainder. Now, there's another way we could word this. If you think about, I can spell it, I promise, remainder. There's another way to word this. The part of the division problem that's not a remainder, but your answer is called the what? It's the quotient. It's just the quotient of your division. Now, these things, couple things to note. And you can write this down if you want, but it's nice to like just gloss over real quick. If the numerator is bigger than the denominator, what's your horizontal asymptote? Numerator gets bigger faster than the denominator. Is it ever going to stop getting bigger? There's not one. You will never never have a slant asymptote and a horizontal. It cannot happen. Never. Okay. So let's do one. Cool. And then we're just going to have a lot of time to work today. Let's get wild. Example. We gonna sketch just like we always do. So here we go. Let's say we're dealing with a first. We'll try f of x is equal to lovely rational function x squared minus x minus 2 divided by x minus 1. Okay, we're going to break this down into parts. What I want you guys to do immediately is simplify. Simplify this, and I'm going to try something. So check it out. We have this lovely factorization. Here we are. We get equals x minus 2 times x plus 1, all divided by x minus 1 still. Does anything fall out? No holes, right? Like I can see there aren't any holes in this. Okay, it's a good sign. If there's no holes and we're completely simplified, what would you suggest we write down? Somebody else is going to try this here in a minute. How would we continue? Okay, yeah, let's find the roots. So check it out, roots. When do the roots of this function occur? When the what is 0? Not necessarily x. So it's 2 and negative 1. I'm going to change the order just so they show up there. How did you get that? What did you set equal to 0 to get that answer? Good. The factorization of the numerator. The numerator is 0 at our roots. Okay. Are there any values of x that break everything? Anything that makes me do something not allowed in math? Hey, I divide by 0 sometimes. I'm never allowed to. But when would I have to divide by 0? For which x value? Okay. There's a vertical asymptote there. Now, whether you write it down or not is up to you. Looking at this, from this form, it can be challenging to see the power. Like, not in this one. I think most of you can at least do the first FOIL and see it's x squared. The degree of the numerator is 2. Degree of the denominator is 1. Is there a horizontal asymptote? Check your list if the degree of the denominator is bigger. What's a horizontal asymptote? None. Can't happen. Okay, however, how much bigger is the degree of the numerator? Exactly 1, which means we have the existence of a what? An oblique or a slant asymptote, which we're going to have to do some scratch work. We get a choice. Are we dividing by a linear factor? That means just x to the 1 of the form x minus k. I'm asking all that to check how we're going to divide. What are my options for division? We can either do it synthetically, which will work here, or sometimes it might not work, and we have to do it how? Long division. Which one should we do? Like, I would suggest you do synthetic if you're going to do this. But is it possible that maybe it's not divided by a linear factor and you have to do long division? Could you all still long divide right now? Okay, I'm going to do it synthetically then. What goes on the outside of my synthetic division box? A 1.
What are you doing right now?
I'm doing the division, so I know that my slant asymptote is going to happen when I divide this, whatever the quotient is.
Oh, okay.
So instead of long division, just because it's so much faster, we're going to do it synthetically.
How come you're not doing... Oh, no, that makes no sense.
Does it really?
It does.
Okay. Cool. So a 1, and then what goes in this top row? 1. Negative 1. Negative 2. All right, let's check it. Like it's hot, I get a 1. I get a 0. And I get a negative 2. Now, I'm still going to put this box here. Right? That's my remainder. What is my slant asymptote then? Y equals... Let's see, this is x to the first plus 0. It's just x, isn't it? Boom. Sorry? So do you agree that this is, if we took a square and divided it, it's just like when we divide x squared by x, it's going to leave 1x plus 0 plus a remainder of negative 2. So I'm just using synthetic division. The quotient without the remainder is where my slant asymptote is going to live every time.
I thought it only works if there's no remainder.
So it's a factor if there's no remainder. And I can tell if it had been a factor, it would have divided out. We just need to get the quotient. Like this didn't simplify out, there will be a remainder. If you ever do this division and it divide, like you get a remainder of 0, recheck your factoring because something must have been wrong somewhere. Cool. All right, we're going to see very similar stuff happening here. And let's just check it. I'm going to graph it, and I'm going to get rid of my synthetic division so I can graph it right here. So cool, cool. What do I need to show on my graph? X values that I need. Negative 1 and 2. Do you guys typically take the time to find the y-intercept? Would it be helpful? It will be, and we should because it's easy to do. The y-intercept happens when your x value is what? 0. Now this one I'm actually going to calculate out, and we'll see why here in a second. I don't care whether we plug into unfactored or factored form, but if I need an actual value and I'm plugging in 0, I'm usually going to commit to here. 0 plus 0, negative 2 over negative 1. If I plug every, or get rid of every x, negative 2 over negative 1 is what? 2. Now on these ones, that number is going to matter, and we'll see why here in just a second. So what I see is I need to go at least above 2, so at least a 3 in the y direction. In the x direction, at least to negative 2, because I'm going to go 1 further, and at least a 3. So here we are. More positive than negative. Cool. And we'll just extend it. I want to emphasize again, I don't really care if you guys just do a big 10 by 10 every time. That does not bother me. You can do that. Cool. So, let's see here. I need to put several things on my graph. What goes first? Order doesn't really matter. What can I put on my graph? Okay, so I'm going to go to purple. Vertical asymptotes. Only one of them, and it happens at x equals 1. Am I ever going to touch this line? No. Okay, anything else that should go on here? Y equals x. Now, the reason that this scale came out square and why I would do this is because I know that for this line, 0, 0 is on it. So it's 1, 1, and 2, 2, and 3, 3. The line y equals x. This is the easiest function that we're ever going to deal with. It's that guy. This is our slant asymptote at y equals 1x plus 0, or y equals x. All right. Now, you can write this down if you want to. We won't touch our slants. We won't touch the slant either. Any other actual things I can put on here that I know of, for sure? I get roots. I get one at negative 1. So I'm going to do these ones in green. Here's my actual picture. So I get a root at negative 1, which is right here. I get a root at positive 2, which is right here. And then because we have it, I get a y-intercept. These 3 points are more than enough for us to graph this function. I'm going to get close to the asymptotes and never touch them in every section that there's a point. So look in here. If you guys have this, I actually want you to sketch your graph. I'm going to come around and look. All right. It's tough, right? All right, cool. So if you want to sketch your graph, I'm cool with it. Remember, we get super duper close to these. Now, how do you know that this graph on this side isn't going to go up like this? It can't touch it, which means one side of it has to go down. It has to go down this direction, since when it goes up, it has to go that way. This graph is going to come up and get really close right here. And it's going to come down and get really close right here. You want to try to draw it? Or are you? Why are you scared? Scared of what? Uh-oh. I don't know how you made it scroll. Right off the bat, though, I see an issue. Don't undo it yet. This, even if she connects it and draws it up, we're going to fail the vertical line test right here. Be really careful. I'm crazy when it comes to getting near asymptotes. this thing can't bend back in. And it's hard to get used to it. I would start here and go up, and then I would come back to here and go downward. Oh, look at that.
Okay.
Cool. Nice. Close enough. Okay, so I'll pass this around here in a couple minutes just to look at stuff. I have a lot of practice, and even still, I struggle to get stuff to hit correctly. I don't know what I want to do. Where I'm doing a bunch of stuff. Strange. Do I redo? Nope, that's the Windows key. All right, I got to Control Y. Or controls. Uh-oh. All right. So they're all there still. There it is. And what was the other one? X equals 1. So don't touch it? Cool. Check it out. Our graph, we had these points. It has to go here. And it has to go really close to this eventually. It was at -1, right? And 2. So it has to go through both of those. I typically would start here and say, look at that. It's going to go up and curve. And then it's going to come down and curve. Cool. A lovely hyperbola just waiting for us. Little tiny extension of it. Did we change much about it though? Okay, so I'm going to give you more time to work on some of these, and I'm trying to decide how I want to do this. Okay, you're going to add problems to your assignment last night. Add. Did anybody do 36 yesterday? Okay, so from the assignment last night, you were going to add number 36. Ooh. $57, $59, and $62. And I might take out one of those in the interest of doing a cooler problem. Love it. I'm not going to take any out, but I'm going to put a homework pass option up. It's an odd, but here's the deal. You got to be able to explain it to me. Come explain it to me tomorrow before class or before school. Number 73. Now, because it's an odd, there should be a lot of takers on this. You'll be able to check your answer, but I need to explain it rather than just see your answer. Cool. All right, get working. We got 13, 14 minutes in here right now, which means if anybody would like to work a problem, I'm happy to do so. Not 36 probably, but if you want another example, we can work another one.